Ciao ragazzi, como estate? Or something like that. What is that? There's LibreOffice in the background. Okay, but we don't care because I tried to make the resolution work properly and it didn't work because I'm using Linux, and since I don't spend enough money on my equipment, it doesn't work when you need it. Maybe I should plug in my presenter stick. Oh. It always takes like 10 seconds to synchronize. Relax, okay? It's under control. So I'm totally not going to talk about Italian hand gestures. I'm here to talk about global warming. But before talking about global warming, I would like to ask, can we make the air condition a bit colder, pumping, because it's really warm in here. And I might start sweating when I talk, and you might think I'm like a creepy, I don't know, football player or porn star or something. Anyway, so I came to Italy by train this time. I confess I'm guilty of contributing to global warming because I've done hundreds of flights to basically unnecessary locations because they are cheap and affordable, and you can fly there in 1 hour, and it's so easy to get to places. And I mean, sometimes you have to get to places, and it's important to, you can actually use an airplane. But honestly, I made this bet with Emily. So she came from Berlin by plane, and I came by a train, and it took me 10 hours and 31 minutes. This is including getting from my house to the train station. And it took you about 5 hours, right? 8.
We're listening to you.
18. It's getting worse. So apparently it takes 18 hours to go to Italy by plane. So the thing is, and I don't want to be, this super politically correct vegan, instructor telling you, stop flying. But honestly, I took the train, and it was such a relaxing experience. I had to change the train once. We were a little bit delayed, everything still worked. And the thing is, when you fly, you're actually wasting hours of your day getting to the airport, getting through security, unpacking your, nail file or something because you put it in your bag or something like that. And you can't do stuff for hours, so you're basically wasting time. On the train, I could sleep, I could talk to people, I could work on my slides. Not on the presentation, on the slides. And it was actually fantastic. So, and please keep in mind that it's not an achievement to get a really cheap Ryanair flight. It's like, oh yeah, I got this 99 flight from, Verona to Poznan. It's really cool. Like I should go to Poznan for 2 days. Like, this is not an achievement. You're a subject to a multi-billion dollars company that is actually in the top 10 in Europe of carbon dioxide emissions now, like Ryanair. Like, great job. And that's, you're not achieving anything by getting this cheap ticket and going somewhere. You're being orchestrated by a transnational beast that is orchestrating the subjects, which are the people, to buy flights and to raise their profits, and at the cost of our beautiful environment. I mean, I know climate change is not happening. It's like a Jewish Nazi communist conspiracy from Russia, and Trump kind of unrevealed it. So speaking about orchestration, today I want to give a presentation about stuff we've been working on, or it's actually. I realized there's like the background is a little bit moving, right? So I had to ask, like, if you look here, it's like moving, and it's okay. Like, you don't have to take pills. It's fine. Like, we all see it. Okay, so I'm gonna speak a lot about state machines and workflows and stuff, because we've been working on using advanced concepts from other programming languages and using advanced concepts from Ruby and combine them and basically raise the bar for business code in Ruby. And this is what I want to talk about. But before we talk about that, of course, we have to learn the basic, essential Italian gesture. I mean, I would like every Italian in this room to help me because I'm still learning. Can you please all do the... Oh, only one hand. So basically, if you ask an Italian, what does this mean? They will say, it means, So I figured out, okay, it basically means everything. The regular expression for this is to be found here. Hey, I'm not finished yet. Okay, so before I talk about, I think the talk was called Enterprise Ruby or something like that. Before I talk about enterprise, I want to talk about what is not enterprise. It's a little bit of a depressing part of my talk, but you just started clapping, so I think we're ready. So when talking about enterprise software, I basically talk about mature software. Yeah? Matureness is what makes enterprise, in my opinion. If you look it up on Wikipedia, enterprise means it's a software used by more than one person, which is basically every software. So we're all writing enterprise. So Ruby is definitely not enterprise ready. So Ruby is probably the most fragile language I've ever used. And the problem is, it's very easy to learn, and it's easy to prototype something, and it's also easy to implement something, but you will have so many runtime exceptions because Ruby doesn't really care about typing. We don't have typing. And Ruby is not made for super critical applications. Okay, I think we all agree on that. You all had this undefined method or nil 100 times in your career per day. And the problem is that Ruby is, according to, I've talked to lots of people from the core team over the last couple of years, and they all agree that the Ruby core code is too polluted with really old code, and it's all in C, and lots of comments are in Japanese that the Americans can't read, and the Japanese can't read the American comments and this kind of stuff. So there's too much code and too many features that no one uses or you shouldn't be using. For example, like singleton class dot eigenclass dot whatever, there's all this meta programming stuff. Like, you don't need it. Really, you don't need it, and it's eating a lot of time for developers to implement those features, or like something like refinements. Like, no one uses them because the idea is not that bad, but they're shittily implemented. Or the fact that you can extend objects at runtime and change the behavior of objects, that is a horrible feature, and you shouldn't be using it, but it's there, and it's preventing Ruby from progressing, yeah, because people are still, Mats is always complaining that he wants to be backward compatible, and that means all the code around Ruby has to support the idea of extending an object at runtime. And enterprise is also not, I think Bojida is not in the talk, so I can rant about Rubocop. He never comes to my talks, it's fine. So lots of companies think that using Code Climate or Rubocop basically makes their code stable and mature. And it's not like that. So I've seen projects, when I consulted in a project, where developers spend 3 days getting Rubocop automatically running when Travis is hit or something like that. And they think, they argue that their code is mature. But it's just, it's a cosmetical parser. It's not telling you, hey, this code is being triggered when that code is changed. That's probably not good. So keep in mind that this is just a syntactical thing that goes through your code and checks the format. Okay. And another thing that is definitely not ready for enterprise is Rails. So again, like, I totally respect Ruby core team, and I think they do a great job. And I also totally love the Rails core team, and I love the talk by Javier this morning about a new autoloader and stuff like that. So it's great to see there's new ideas coming. But if you look at Rails from a little bit negative standpoint, I'm a very negative person. I'm German. So if you look at Rails from my standpoint, there is, all I can see is they are repeating and rewriting gems that are already there. For example, active storage. There's the wonderful Shrine gem. It's much better than active storage, but no, it has to be rewritten by the Rails core team. Or, I don't know, they are throwing in some active action text or whatever it's called. Like, this is not, like, I don't need a CMS widget to write better Rails applications. I have different problems with Rails. Like, we need solutions for, I don't know, the callbacks and validations being triggered when you don't want them and this kind of stuff. We don't need like action cable, okay? So Rails is not fixing the problem about mature software as well. Yeah. So let's talk about what is enterprise with all those negative things in mind. when I talk about enterprise, I think of a maintainable software system. Yeah, something that you enjoy working with every day, and that you enjoy working with 5 weeks after you come back from holiday. Because when you come back in a Rails project after 5 weeks on holiday, it is not funny to work with it. So basically, it boils down, you want to have a stable, solid foundation that doesn't break when you change something in point A. Point Z or X or O is still working. And that is what I see as enterprise software. That is something I would sell to a client, and I would tell them, I'm pretty sure it's going to work. And I'm pretty sure it's going to work because I'm able to test the software properly, okay? So again, like in Rails, it's really hard to test specific components. It's only, all you can do is run controller tests or functional tests, and then you hope that you covered all the scenarios. This is why I was asking Emily about testing things like when there's a network problem or something like that. I mean, you don't need to test that on a web application, but generally speaking, you should focus a lot on testing because you want to have all those possible side effects eliminated from your code. I mean, you don't want to run, I don't know, let's say an airplane from Tesla on an untested Ruby on Rails application. I mean, you know what I mean, right? So basically what we need to write more stable software is we need more abstractions, yeah, more building blocks in our, I can hear this thing clipping. Is that a problem? Because I like to clip. So what we need is building blocks, yeah, both on the language level and on the framework level. And there is a bunch of really cool projects in Ruby in the past couple of, like 5 to 10 years, which came up with a lot of new abstractions that you can use to build better, stable, mature software. And the other thing is we definitely need more tooling around software development. So just reading a stack trace in Ruby when you use a couple of frameworks and you have like 5,000 lines of code, you don't even know where the exception comes from. You just see, okay, there's an exception, something is wrong. Undefined method, hello or nil. Have fun debugging. Or when you want to inspect code, you want to see how are the objects related to each other, or how many dependencies do I have in a class, this kind of stuff. This is tooling, and we have horrible tooling in Ruby. When I look at Elixir, they have great tooling from the beginning. I mean, it's not fair to compare Ruby and Elixir. They rewrote Ruby in a nice functional way and added all the stuff that's missing from the first day, but they care about tooling. And in Ruby, I don't know, we're talking about like array.pretend. Yeah, cool, addition in 2.6, I can't wait. Like, why? It's a method that is alias. That's not a feature that helps you to write better software. Because at the end of the day, literally today, I want to write frameworks, or I want to provide tools to people writing software that makes them write enterprise stable software. So they go home and they play with their friends, they play with their kids, they enjoy a drink, they go on holiday for 5 weeks and they come back and they still want to work with the code. So that is my personal goal why I write frameworks, okay? So it's not even that I want to reach insurance companies or Ryanair to use my stuff. I want to empower people, or we in the project, everyone who writes open source wants to empower people to write better code, like more stable and testable and all the good stuff. And I'm really sorry, but I have to mention a little bit about my project, Trailblazer. I'll talk about it. Some people were laughing about it prior to this talk. Like, you always mention Trailblazer in your talks. It's like, okay, if you invite someone who works on a specific project, they're probably going to talk about that project, right? I mean, you also like to talk about MongoDB and Elasticsearch. and so just as a disclaimer, you're going to see something about Trailblazer. So I was talking about abstractions and tooling kind of as my way of improving software. And so one thing for example, we did in Trailblazer is we provided more abstraction layers to Rails applications or any kind of application. And it doesn't really matter what you see here, but we added things like a new directory structure that is focusing on concepts and not on technology. And then in the concepts you have technology like operations and cells like view components and representers to parse stuff and all this kind of thing. So there's new layers of form objects to model problems in your application and solve them, obviously. And what we also did is we added interfaces. So I know, like 7 years ago, the service object was this mystical thing. Like, oh, have you ever used a service object? Yes. Oh. So I mean, now in every application, in every good application, people are using service objects, right? And so the idea is encapsulate code that shouldn't be sitting in the MVC stack as they do in Rest. The code sits in one instance and is encapsulated. So what we did in Trailblazer is we added this concept of an operation, which is basically modeling a function in your application, like updating a comment, archiving, I don't know, a blog post, deleting a user. You know, the public functions of your application, you model them as an operation in a class and blah, 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 and they all have the same interface. So you have a call method, the call method gets all the dependencies and returns a result object. And it looks really like ridiculous right now, but this was a step in the right direction because lots of projects do, I mean, they didn't copy that from Trailblazer, it's common sense, but this, like having objects that model functions without any public interface is an achievement in the Ruby community. I'm really glad that we are going this way. And you know, so for example, you call this comment update and it does something, it obviously updates a comment. Oh, I think I saw Bojida. Oh, did you just arrive? Shit. Okay, so you can ask the result object, hey, were you successful or not? And you can ask the result object for dependencies that you need on the outside after calling the operation, this kind of stuff. So we introduced interfaces. It's really important in a complex software to have interfaces defined, you know? We don't have that in Rails. You have a model and it has like 300 methods and you use them in any way you want and in the end everything breaks and you don't know why, and that's kind of not cool. So what we did is we introduced an operation. In Trailblazer in the version 1 there was this class and it had a process method, and the process method is basically where you do everything. So people were really excited, hey, we got service objects, woo, let's use them, and it ended up like this. So you know, since you do everything, I mean, at least you do everything in one encapsulated method that doesn't have access to global, I mean, it has access to global variables, but you can't screw up local state because it's a method. So at least we had this. But then people started to find out that they can do everything, and they used whatever Ruby provides, which is ifs and else and methods, and started to kind of model their workflows to update a comment in this example, and just wrote everything into that process method. So it was a big problem. So in 2.0, I decided to break everything, and I broke everything. So people get really angry because we introduced this new API, or it's actually a DSL, so you can model what happens in the process method declaratively. And you look at this and you kind of like, what the hell? So if you look at the beautiful diagram, I want to bring your attention to my drawing skills on the train with a vacuum tablet. So here, for example, we hit some, I don't know, some animal on the tracks or something. So if you look at this diagram, you instantly or intuitively understand what is the semantic of this operation, yeah? And this is called a railway, and it's really like a really common pattern that is used in many, many Ruby frameworks and many, many other functional frameworks. I'm actually really happy. This is kind of cold up here, so it's great. Hey, global warming. Anyway, so who can guess what this is? What, salad? No? Spaghetti carbonara. No, spaghetti pomodoro. So if you look at, don't look at the spaghetti. There's lunch in a couple of minutes. So the normal behavior of a railway is like you define steps or tasks, as we call them now. And so normally, in a great case, I'm becoming a movie director, so I'm practicing with animations in LibreOffice. So in the perfect, like in the happy path, you literally just step through the tasks that you added with step, and you just perform whatever the operation is supposed to do. And sometimes things might go wrong, and as soon as something goes wrong, it jumps to the failure path, the lower one, and it will only execute steps that sit on the, I love that feature so much. And once you know how to do it, it's really simple. So I've explained this pattern too many times. I'm really bored of it. So you kind of get the idea. You define two paths, and then when something goes wrong, it jumps to the error track and skips the rest on the successful track in the top. So that's the idea of a railway, and it takes away the pain to have all those ifs and else, because Trailblazer or the railway implementing library takes care of that. Okay, so if something is wrong, I'll execute the rest on the failure track without you having to do anything. All you have to do is you define that path, and then you define what is a task. Yeah, and a task in Trailblazer is just a callable object. So in this case, it's a method, and it's called find model, and it receives a context and parameters, so you can pass in anything you need. Trailblazer takes care of that, and then you can write to that context, and you can say, in the end, you can say true or false, and true means everything was okay, and false means something was wrong. So if you look at this little diagram I extracted from the original diagram, true means I want to go this way, and false obviously means I want to go this way. So I used GIMP here. I didn't draw that myself with Wacom. There's a filter for explosions. It's amazing. Hey, I know, it's pretty cool. I can show you if you want to learn how to do that. Okay, so you get the idea of have an operation, have an object that does one thing, and have a DSL that helps you to do error handling automatically. And the cool thing was that we had really nice testability, because suddenly you can unit test your functions. Yeah? Updating a comment, you don't have to do, I mean, you can still do HTTP testing, but you have a way to test all the functionality with one call. You literally just call the operation and test the outcome. And this is something that is completely missing in Rails, for example, because if you want to unit test your code, you either use an abstraction like an operation, or you have to do a controller test. But then again, you're running HTTP stuff, and you're testing stuff you don't want to test, because I want to test, does my business code work, and not does my rendering work in this case. And so it's a really easy way to achieve better testability with more abstractions. I mean, it's not rocket science. The cool thing that we added recently in Trailblazer 2.1 is that we have tracing. So you can run. And this is kind of the first tooling experience I want to give you. So you can run an operation, and it prints you the path it took. And for a simple operation that we just had, it's not really like breathtaking. Talking really fast is breathtaking. But if you can also nest operations, and I used to explain how to nest stuff, and this is the DSL, and this is the API. It's really boring. So basically, when you have nested operations, an operation step calling another operation, and you use tracing, you can see what path it took. And this is amazing. It's an amazing experience to find out, like, for example, let's say it would end in end.failure. So something went wrong. You don't know where and what. You just use tracing, and you see exactly the path the execution took. And this is a really simple feature with Trailblazer, but in Ruby, this is impossible, because you don't know what methods in what if blocks and what else do you want to have in the tracing. So Ruby is simply too fine-grained. We don't have the concept of a task or a step or an operation. Everything is a method. And so what we're trying to do is to raise the tooling experience by introducing things like tracing. And my absolute favorite feature is the what the fuck method. So it's amazing. Like I love it. I use it every day, even if I don't have problems. So the what the fuck method is basically it calls the operation with whatever arguments you need for you, and in case of an exception, if something goes wrong in your code, like a physical exception. I mean, exceptions are not physical because it's all in a computer, but you know what I mean. So in case of an exception, it'll show you the trace, and it shows you the last kind of breakpoint it could find where the exception happened. And this is extremely helpful. This is amazing. And if you compare that to a stack trace in Ruby with 400 trace lines, and then probably active model, I don't know, validator callback line 34 or something, you have no idea what happened. And I find it really frustrating. And it's not that hard to provide better tooling. So the what the fuck method basically was the reason I rewrote Trailblazer 2.0 to 2.1, because I wanted to have tracing, and by accident there came a lot of nice new possibilities. So I feel the pain of people who were using Trailblazer before that feature, because if there was an exception, you had to go through the operation manually and find the error and make begin rescue and puts. I love puts. But with everyone loves puts, come on. Who's using a debugger, by the way? Like, is anyone using debuggers? I see lots of people. Oh, wow, you don't need it anymore. It's all here. Okay, so a quick new gesture is the go away gesture. So if if you insult someone, for example, in Italy, they might say like, and what you should do if someone sends you away is you should ask this way, and then walk away. But be nice, okay? Be gentle. Italians are great. Okay, so this is another drawing I did before I jumped on the train. You can see the difference, right? So we had, so we did a lot of work on this railway stuff, and doing automatic error handling for you, and making it a really nice experience to work with Trailblazer without having to do all the manual debugging and this kind of stuff. So we started adding features like fast fail, or fail fast, I think it's called, and pass fast, so you could like error or pass out of steps and end the operation beforehand. So basically we started to add more, I call it wiring, like because this is like an electronic circuit and you kind of add new wires. And I wasn't really happy about adding those features, because to me it already smelled like maybe we're moving to some to a state in Trailblazer where we want like real workflows, not just the linear ones going towards different ends. And this is also when I started working for the police. I always do this joke and no one laughs. So I actually worked, I think last time I was here, there was shortly after I started working for the German police, so they use Ruby. Yeah, the state of Lower Saxony, Niedersachsen, they use Ruby. And the funny thing was, they had lots of diagrams where they show their workflows and show rules of, I don't know, for example, a criminal inquiry or something. When you want to find out why this guy who stands up is a criminal, you can do that, and it will. And they had all this stuff defined in diagrams, and the diagrams had nothing to do with the actual code, and the actual code had nothing to do with the diagrams. Not to speak, no one even checked the diagrams. But I found all those diagrams, and I loved the idea. And I found out they are all written in a language called BPMN. If you talk about business, you need business people. BPMN means Business Process Modeling Notation. Yeah? It's a concept from the Java world. And it's actually amazing. I love BPMN. I've read like 20 pages in a book that has 400, and it's enough to understand BPMN. And I'm going to spare you the time, because BPMN is super simple. Yeah. So it's a diagram language that adds semantics, behavioral semantics for elements in the diagram, and it defines your business workflows. So you already saw this workflow earlier in my slide, and obviously you understood it instantly because it's a very simple workflow. So this is a secret, not to be published workflow from the police. Can you please stop filming for a second? So, so basically, my first job was to improve a system to do those inquiries about criminal records. Yeah, for example, if Emily Stolfo wants to get a weapon in Germany, she wants to get the Waffenschein, as we say, she has to apply, and she will get a background check. And the background check is a very simple process. So I use. Can you guess what this is? If you guess it, I'm gonna buy you a shot later. What is? Who was that? Shot. So I'm gonna quickly run you through this diagram because it's a very interesting thing, and I love state machines. Do you feel the excitement about state machines as well? Like, go. No. Every developer loves state machines. It's just, you look at it and it's like, this is engineering. Okay, so the whole thing starts with you fill out a form with a name, Emily Stolfo, birthday, 31st of March, 2001. No, that's my birthday. And you send that form or that whatever document into the state machine, I mean, so to speak. So you validate that. And if it's valid, the state machine is going to say, hey, I'm valid because there is a send event. And then it's going to wait in the next catch. So you have throw and catch events. The throw event just tells the system something happened, and the catch event says, wait for a specific event to happen. Okay? So we validate that thing, we tell someone else it's valid. We don't know who we're going to tell this. We just tell it's valid, and then we wait for the next event, which tells us to actually create that inquiry. So this is basically running a reform contract or running dry validation or something like that, and then you wait to actually write that to the database using active record. So if you receive the create event, it writes it to the database using active record or whatever, and then it queues that a specific document in a Redis queue, because the document that we just created needs to get picked up by the real system to do the background check. And the system, the real system, at some point will say, hey, I picked up that document. So it sends a pickup event, which is received where the pizza is right now. And what it does is, it runs a little bit of code. I don't want to go through all the stuff. Actually, I also forgot to do one stop. But whatever. What happens is the system, the real system, picks up the document, runs a lot of background checks, you know, on your Schufa if you have any debts, because people with debts are can be exploited to do criminal things. That's what I learned at the police. And it checks if you have any findings, which is kind of criminal records, and it checks if there is any if an investigation going on against you, and all this kind of stuff. And at some point, the system will return the findings or the results from the actual inquiry to the, and this is where I did a mistake, to the actual state machine, and it's going to process the findings, and it's going to save the response from the real system somewhere in the database. And then, so what we have now is, we filled out a form, we submitted the form at some point, we ran the data through a real police system. The police system gave us a response. 5 days later, 10 days later, 2.5 weeks later, it doesn't matter. It's a long-term workflow. We got a response, and we saved that response in our database. And now we're waiting for an officer or a clerk to download that, because it's a requirement by the police that your original inquiry can only be deleted if you download a PDF. Yeah? And this is modeled in this state machine. So we got the result, it's ready, sitting there. So next 5 days later, an agent might click on, oh, there's inquiry Emily Stoffel. Let's see her criminal investigation background. I mean, I'm sorry, I'm using your name. I hope it's okay. And so the clerk or the agent clicks a link, download PDF. So this sends a downloaded event and does a couple of things in Ruby to mark the object as downloaded or whatever, renders the PDF, blah, 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 blah. And now the inquiry and the finding is actually ready to be deleted. And what can also happen is, yeah, so if you click delete, it'll send a delete event, and the actual active record.delete thing will happen, and the thing is gone. What can also happen is that, you can also delete an object before it gets picked up by the other system. So you can have branches and stuff. What can also happen is that another event happens earlier than the actual delete clicking. So if someone waits for 90 days and they don't download, the thing automatically gets deleted. So there's a lot of, don't worry if you don't understand all the implications here, but it's a very complicated, not very complicated, but it's kind of complicated process. It is completely modeled in an understandable diagram language. Forget about those crystal things and all this kind of stuff. This is the basic low-level diagram. I just copy and paste it because my Wi-Fi was bad on the train. Actually, I prepared this weeks ago. I'm not kidding. And but what you do is you define your workflow in combination with Ruby in a very, very simple and easy way. So you might ask yourself, why the hell should I use this? I mean, what is it good for? And the other thing is you have to learn is, are you sure this is going to work? I mean, come on, this is too crazy, right? I've learned that the second gesture is really good for stuff in Italian. So the thing is, you're modeling something, a workflow, in a very understandable way. You're leveraging existing semantics and standards from BPMN, and be honest, it's not that crazy. It looks beautiful. It is very descriptive, And the fact that you don't understand events yet doesn't make this, it's not a showstopper. Actually, events are really simple. And I'm not going to go too much into the details about the events, but theoretically, intuitively, you picked up the idea, how does an inquiry work, a secret inquiry, not to be published, confidential, how does it work in Germany? So what we did is we spent a lot of time and money on implementing a diagram editor where you can edit following the BPMN standard mixed with Trailblazer semantics. So what you can do in the editor is nothing amazing, but it's basically the simplified version of a real BPMN editor. If you use, I mean, I get the idea that people have problems with Java, and because if you use a real BPMN editor, you would have 17,000 options here, 15 tabs up here, and on the right-hand side, you had some panel to organize, I don't know, templates or something. So our editor is really simple and is also very bare bones at the moment, but it helps you to organize huge projects with lots of workflows, and it helps you to, communicate with product managers and say, hey, is that actually the kind of workflow you were thinking of? Do we have to download the inquiry before we can delete it? And they look at the BPMN thing and say, yes, it is. That's the way I want it. And that's the goal of BPMN, to make developers and business communicate in a visual language, okay? Another cool feature is you can also, instead of modeling and then using that in Ruby, you can also render existing diagrams. So you use the developer gem, again, you throw in an operation or an activity, as we call them now, and it's going to render the beautiful diagram for you. So you don't have to go through the code and, oh, what step fail, pass fast, whatever. It renders a beautiful image. I like images. We are human beings. Our brain is optimized for visual images and not for reading through complicated code. Okay. And another feature that is coming at the moment is that we have tracing. I mean, tracing works on the command line, works automatically with workflows, but we also have tracing in the editor. I mean, I'm sorry if this sounds a little bit like a sales presentation right now, but it is amazing, really. We have a prototype working, and you can see the trace, the path the workflow took over many days, and you can also see what went in and out of every step. And it's so nice and good for debugging. For example, let's say the parsing breaks, the parsing of the response, and then you can inspect the response, what went into that state, and see, okay, the JSON was malformatted. So maybe we should talk to the real police and tell them, hey, your system sends us bullshit. And you found that out with tracing and tooling that comes automatically built into our workflow system. This is really my absolute favorite feature, the tracing that shows you the actual path, including input and output of every task. Like, having this in Ruby, we are far away from that. So you look at all this stuff I just showed, and I know that people are really worried about editors and code generators, and say, we've learned that code generators don't work because you can model workflows and then transform them into Ruby and use them in Ruby. Okay, but what happens is you model them in the editor, or you use a DSL in Ruby directly if you don't want to use the editor. And this does not get transformed into code. This gets transformed into an unreadable green string. So basically what this green thing is just an array or a hash of structs. And it describes that diagram in a very simple hash with Ruby structs. So that is all the generator does. There is no code generated, no runtime code. It's basically structural code that we generate. And that structural code you then have to implement in Ruby. So what this unreadable code snippet says, and I don't want you to look at it because I made it really fuzzy on purpose. So now you in Ruby have to say, all right, I got this structure. I want this task to be this kind of Ruby object. I want that task to be that kind of Ruby object or method or whatever. So you have to tell in Ruby how you want to implement that thing. Yeah. So we separate modeling and implementation. And again, every step or every box you saw in those diagrams is just a callable Ruby object. So it can be a method, a class, a lambda, whatever you want. All it has to have is a call method, which is wrong in this slide. Sorry, I suck. Yeah, and the idea is that every step communicates what path to take using either true or false or real signal constants. So you can have more than two outputs. But the idea is the task does not know where we're going. The task only knows what is happening. Yeah, the task only knows, I want to go, I want to communicate everything is okay, valid, or something went wrong, or there was an exception, or whatever. So that's the idea of the separation of modeling and implementation. And to confuse you even more, I have a few months ago, I discovered an amazing feature in BPMN. It's called collaboration, and this is how you connect activities or workflows with each other. So the workflow I just showed you about the inquiry is what I call a library workflow. So that's the state machine for a business process, completely unrelated to if it's a web interface or if it's or if that process is being run by a command line tool, or if this this workflow is run by like an HTTP endpoint, like a REST backend. So what you can do, and again, like, don't worry about the details. This is the original diagram we had. This is a diagram. This is the diagram for a web surface. So I'm going to show you, like, really quick. If you can guess what this is. What is this? Short for you. So I'm going to run through it real quick because it's kind of boring. So again, you model the workflow of your web interface. So you render an empty form, you wait for it to be submitted, you basically tell the other state machine, hey, validate this and tell me the result. And then you wait for the result from the other state machine. And then, yeah, so it can be valid or it can be invalid, but that's what the other state machine tells you. And then whatever happens, you take action. For example, if it's invalid, you re-render that form, with the errors and like saying name, I don't know, Emily Stolfo is too long or something like that. I mean, the typical erroring form. And that is, again, controlled by a state machine. But this state machine doesn't know the rules, the business rules. It gets the business rules from the other diagram. And just a really quick example. This is all normal Ruby on Rails code. Yeah? Ruby on Rails code, or whatever you use, Hanami probably, because it's my personal preference. You use actions and you use forms and you still use your code, but in that code you call the workflow. And don't worry, you don't have to understand everything right now, but you call workflows from your normal application code, and the workflow will take care of the rules and the control flow and give you results, and based on the result, you render an erroring form or not an erroring form, for example. Yeah? So you instruct the workflow by sending it events, and the Trailblazer takes care of the rest, and then you do your rendering code manually, the same way you did it before in Ruby on Rails or in Hanami. So basically, this is called a collaboration. So you can tell if I want you to validate, I'm going to send a validate event, and it's going to trigger the library workflow. And so you can also do that in the editor. So you can basically instruct external workflows to work together. It's called collaboration, and I really love it because it helps you to write state machines for business processes and for UIs or for REST APIs. So just a quick example. What is this? If you guess that, you're really good. Yeah. No. Limoncello. This is limoncello. You're really good. So just quickly, like if I run my web UI, oh, come on, limoncello is the best. If I run my web UI, I basically run the upper state machine, and it will instruct the other state machine, hey, please do the validation for me and send me the result, and the result is being sent back to the original machine, and so on and so on and so on. So it's a really cool way to plug together workflows and reuse workflows by using a collaboration diagram. This is the arrows. This is me again on my Wacom tablet on the train. You can do that in the editor, but the editor didn't work without Wi-Fi. And again, this is all stuff. It's super simple in the editor, and it's super simple in Ruby. Like, you just have to provide the messaging path and this kind of stuff, and then Trailblazer does the rest for you, if you want that. So I'm kind of finished with my presentation. This is the hand gesture I learned from my friend Manu in Australia. So we used to live together, and we went surfing every day, and then he always did this. And I say, like, what the hell are you doing? It's like 2 more waves, and then we go home. So this is how I learned that. It's basically for Linux users, macOS kind of. Okay, so The whole stuff I showed you is pretty mature right now. It's all relicensed under LGPL version 3. People freaked out. Oh my God, how can you not do stuff in MIT? Why do you do LGPL version 3? So I hired a lawyer specialized on licenses to figure out what implications this license change has for you, and it basically doesn't have any license implications for you, so you can use LGPL version 3 code in your gems and still make the gem open source in MIT if you want. LGPL just says, if you change Trailblazer code, you have to publish those changes. But no one is going to sue you if you change Trailblazer code and don't publish the changes. So don't freak out about the LGPL version 3. It just raises awareness for licensing, because open source is a lot of work. Okay, so for you guys to take home, for me, enterprise is leveraging advanced concepts, which is reflected in my bad formatting. So use things like workflows or activities, operations could be built into the language itself, and you wouldn't even think about it anymore. You would just use them. You use automatic error handling. Like, why are we still in the Stone Age in Ruby using like if else and those funny stack traces? And really trust non-magical solid frameworks. You're handing over the control flow, only the control flow, to a framework like Trailblazer in this example, and there's nothing wrong with it because there's no magic happening. It's very explicit. There is no automatic inflection of constants and this kind of stuff, because that's what Rails does. I'm sorry. And in active record, for example, if you say if you say belongs to user, it will automatically find a constant or something like that. So there's no magic in this framework, and as far as I know, there's no magic in the Hanami framework. And Hanami also gives you a lot of advanced concepts, and trust those frameworks because they make your code better, okay? There's nothing wrong with it. And stop reinventing. Like, I can't see how many railway implementations there are in Ruby right now. There's like 50 gems. Why? Like, it doesn't make sense. And also in Rails core, why do they keep reinventing stuff like storage? There are gems that do it much better than people who just started rewriting it. So stop that. Please use existing stable software. It's a great thing. And if you can, use visual tools like the editor, because we are human beings. We are made for visual images and not for going through like 400 level stack traces. So that's kind of my takeaways from you. I want, again, to have your attention for a quick moment because I made this amazing cinematic effect.